In today's session, we will discuss Napier's analogy. We'll begin with our first condition, the first analogy that states that tangent of a minus b over 2 that's given by a minus b over a plus b times cotangent of c over 2. Similarly, we have two more analogies. I'll do the proof for the first one, and the remaining two will be left as an exercise for you to try out. Let's do that. We will start with our first one. We have tangent of a minus b over 2. We have to show that this is equivalent to a minus b over a plus b whole multiplied to cotangent of c over 2. Now you can start either from the left hand side or from the right hand side. If you start from the right hand side, it will be pretty easier to solve. All we have to do is use the law of sines and replace the value of a and b with their sign counterpart. Let's state the sign law of sines first. So let's say we have a triangle. I'm considering here an acute angle triangle ABC. Now the side opposite to angle A, so that will be represented by the letter A in lowercase. Side opposite to angle B, which is AC, will be represented by B in lowercase, and the third side AB, which is the side opposite to angle C, that will be represented by the letter C in lowercase. Then we have the law of sines. Or the law of sines states that the ratio of side A to that of sine of the angle opposite to it, so that will be angle A, equals to the ratio of side B to that of sine of the angle opposite to side B, so that's angle B. And this is also equals to the ratio of side C to that of sine of the angle opposite to C, so that will be angle C. So this is the law of sine. So here we can equate these three ratios to some constant, and this will help us obtain the value of a, b, and c, which we can substitute in the right hand side, that's a minus b over a plus b, and solve it to get the left hand side. But for this particular problem, what I'll do, I'll start from the left hand side. So let's begin. So on the left hand side, we have tangent of a minus b over 2. So what we can do, we can convert the tangent to its equivalent. Cosine, sine and cosine, the ratio, we know that it's the ratio of sine a minus b over 2 to that of cosine a minus b over 2. Now what I'll try to do here, I'll try to make the numerator as a difference of the trigonometric function sine a minus sine b, or sine theta minus sine phi. To do that, what we'll do, we will multiply the numerator with 2 times cosine of a plus b over 2. Now that's an extra term, so we'll need to divide it by 2 times cosine of a plus b over 2. Then we have in the denominator, so what we'll have to do, we'll have to multiply the denominator with 2 times sine a plus b over 2. Now that's an extra term, so we're also going to multiply to the numerator. So we have 2 times sine a plus b over 2. Fine. Now the reason why I've written in this particular fashion, because 2 times cosine of a plus b over 2 times sine of a minus b over 2, that is the sine a minus sine b, and the denominator is simply sine a plus sine b. Fine. And here we have 2 and 2 cancelling out, so the ratio of sine over cosine, so that's our tangent function. We have tangent of a plus b over 2. Fine. Furthermore, we know that in any triangle ABC, the sum of the interior angles, that sum up to 180 degrees. So that means we have a plus b plus c, so that sums up to pi radians, or 180 degrees, which means we can rewrite a plus b as pi minus c. Now if we take the tangent, let's do one thing, let's divide both sides by 2. So we will get a plus b over 2, this will be equals to pi over 2 minus c over 2. Now if we take the tangent on both sides, so we have tangent of a plus b over 2, which will be equals to tangent of pi over 2 minus c over 2. Now the tangent of pi over 2 minus c over 2, that's nothing but the cotangent function, so we have cotangent of c over 2. Meaning we can replace the value of tangent of a plus b over 2 with cotangent of c over 2, which gives us, now we have sine a minus sine b whole divided by sine A plus sine B. And tangent of A plus B over 2 will become cotangent of C over 2. Now, what we'll do, we will have to replace the value of sine A, sine B with the respective sides. So all we have to do is, since we have already stated the law of sine, so we will suppose that let these three ratios be equals to some common constant, and we're going to refer to it as 1 over lambda. In doing so, now we can specify our sides or sine A. So sine A will then be equals to A times lambda. Sine B will be equals to B times lambda. Similarly, we can define sine C as well, since we only need sine A and sine B. So therefore, our final result will become, we have lambda multiplied to A minus lambda multiplied to B, divided by lambda times A plus lambda times B times cotangent of C over 2. Now here we can factor out lambda from both the numerator and the denominator, and this should finally give us A minus B over A plus B times cotangent of C over 2. Which is the expression on the right hand side. So hence, we have successfully showed that the tangent of A minus B over 2, so that's equivalent to A minus B over A plus B multiplied to cotangent of C over 2. Similarly, the other two can also be proved. So if we have tangent of B minus C over 2, then on the right hand side, we're going to have B minus C over B plus C multiplied to cotangent of A over 2. And the third analogy will be tangent of C minus A over 2. So that equals C minus A over C plus A multiplied to cotangent of B over 2. So this is the Napier's analogy, also sometimes referred to as the law of tangents.